Given a list of digits, we have to determine the integer that it represents. So the idea is something like, let's say we have a number like, or a list like 8351. So to construct an integer, we'll basically use this idea. So the number can be broken down into 8,000 plus 300 plus 50 plus 1. And this math gives our answer. So let's look at the code here. The idea is to use the power notation of integers to construct an integer from the given list of digits. For example, 8351 can be broken down into 8,000 plus 300 plus 50 plus 1. And notice that the power of 10 for the first digit is the 10 to the power length of the sequence minus 1. In this example, the length of the sequence is 4. 8351 is 4 digits. And the power for the first digit is 10 cubed, which is 10 to the power length of the sequence minus 1. And this power decreases by a factor of 10. So 10 cubed, 10 squared, 10 to the power 1, 10 to the power 0. So we'll iterate over this list and build our integer by exploiting this value. I'll show you how. So this is the function, takes in a list of integers. This is a required integer which we'll build over time. So the power of 10 is initially set to length of digits minus 1, and place value will be set to this. So 10 cubed, basically. So we start with the first digit. The value will be set to place value times digit. So the first value, so the first digit, the value is set to 8,000. And required into first value set to 0. And now it changes to 0 plus 8,000. And this is what we get after one iteration of the loop. So the place value is set to decrease by a factor of 10. And the reason why we use an int function, we surround this value by an int function, because Python automatically promotes to a higher type when it performs arithmetic. So when you perform division, it already promotes to the real values, the decimal numbers. So you'll get something like a point, some 0.00 in your integer, which is something we don't want. So this converts 100.0 to 100. So the next digit is 3. The value will be set to 3 times 100 because we decreased by a factor of 10. And then the required integer is set to 8,000 plus 300, which is 8,300. And again, the place value is decreased by a factor of 10. The value is then set to 5 times 10. And the required integer is set to 8,300 plus 50. And then again, we decrease the factor to 1. And the value is set to, the last digit is 1 times 1. The required integer is updated to accommodate this 1. So the integer becomes 8350 plus 1, which is 8351, which is the required integer. And this line does not really matter because this is the last line of the loop. So yeah. And let's look at some examples. Let's say the list of digits is set to 75210. So this will give you this answer, which is correct. Let's say we change the list to have something like 0, 0, 0, 0. And it still give you the correct answer, which is 0. And if we, let's say, change this to have this, it still give the right answer, which is 1. That's because the zeros don't really matter, and print the required integer.